All right, we're going to take notes over weather. So go ahead and write the title, Weather. Meteorology is the scientific study of the atmosphere. So a person who actually studies weather is called a meteorologist. So go ahead and write this. All right, so what is weather? Weather refers to the state of the atmosphere at a specific time in a specific place. Remember, climate is a year-to-year average, but weather is what's going on right now. In Texas, we know it changes quite quickly. And we're also going to look at some of the factors that affect weather. All right, so go ahead and write what's underlined. Temperature is the measure of the average amount of motion in particles. So when we use the thermometer, these particles hit this area of the thermometer, transfer its energy to the liquid inside, and the liquid inside becomes less dense and starts moving and actually rises up the thermometer. So again, temperature is the measure of the average amount of motion of those particles. Right, what's underlined? Temperature changes when molecules either slow down or speed up. So as it gets cold, those molecules will slow down. If you're standing outside, the molecules aren't hitting your skin as fast, so it will actually feel colder. Hot air is where the molecules are moving a lot faster, bouncing around more, and when they're hitting on you, hitting on your skin, it actually will make you feel warmer. All right, wind, what is it? Well, we know it's the movement of air molecules, but what actually causes it? The difference between high and low pressures is actually what's going to cause the wind, and the high and low pressure is caused by the uneven heating of the earth. So one area of the earth, the sun may hit more, and it'll actually cause the air to rise here, and then it'll be cooler in this area, and the air is going to move from one place, more dense area, to a place of less dense area. So key thing here is the uneven heating of the earth. Right, what's underlined? Wind chill, we always hear about this on the weather. Well, wind chill is just the perceived temperature change when we're outside on our skin. A lot of times it's just because of the amount of moisture in our skin. As wind blows across it, it actually draws the heat away from our skin and makes us feel cooler, just as it does in the summer when we're sweating. It does the same thing in the winter. It's going to cool us down and make us feel colder than the actual air temperature. Right, what's underlined? And this right here is an anemometer. This right here spins around. It'll give us a wind speed. So an anemometer measures wind speed. Go ahead and write it. All right, humidity. Humidity, we always say it's the amount of water vapor present in the air. Relative humidity is what you see on TV when you watch the weather. Basically, if it hits saturation, that's when it's probably going to rain 100%. If we talk about 15% or 50% at that particular temperature, that just means that 50% we're halfway there to reaching the saturation point. Right, what's underlined? All right, the dew point. We also hear this on the weather. Well, this is when a temperature is reached, the moisture in the air is able to condense from a vapor into a liquid. So an example would be here with your glass. You put ice in it. As the air around the glass begins to cool, the water vapor surrounding the glass will condense on the glass. This water vapor is all around the glass. You just can't see it. But when the glass itself gets cold enough, the air that's around the glass, the water vapor will condense. Same thing with grass. Over here, water vapor is always coming off of the grass. There's always transpiration taking place. And eventually, when it gets cold enough, that water is able to condense on the actual blades of grass. So go ahead and underline that. And a hygrometer is an instrument that's used to measure the moisture in the atmosphere. So you can see right here, 0% all the way up to 100. You also hear about atmospheric or barometric pressure. That's just the pressure exerted by air molecules. As you can see down here more towards the surface, there's more air. and it's actually pushing down on the surface. Well, we hear about high pressure systems and low pressure systems. Again, that's just caused by ascending air, which is going up, or descending air, which is going down. As the air warms, it will actually rise up. And when it rises up, the air is not able to push down. So this will be a low pressure system. As it cools, it will drop. So this here is actually pushing down. So this right here would be high pressure because it's pushing down on the ground. And a low pressure is where the air is going up. So there's no pressure here, very low pressure. All right, so we got an example here. This is just a regular map. You can see a high pressure system where the air is dropping down. Well, you can see the high pressure system here. There's not any rain around this high pressure. Well, it's because the air is being pushed down. Water vapor can't rise to form clouds. When it can't rise to form clouds, it won't form rain. So around a high pressure system, it's going to be sunny. Right, what's underlined? All right, it's just the opposite for low pressure. Low pressure here is where the air rises and it actually carries the water vapor up through a colder atmosphere. And when that water vapor goes up through a colder atmosphere, it will condense into a cloud and it can rain. So you can see right here, low pressure system, rain on the front edge here, snow on the backside. So you get precipitation around a low pressure system. It just so happens that this cold front's coming through and it's causing the precipitation back here to be snow and ice. And on the front side, it's just rain because it hasn't reached there. You can see the warm front here. So with a low pressure system, key thing is it's going to be cloudy and rainy. Right, what's underlined? So you get the heating of the ground, low pressure, air rises, carries the vapor up, and it will condense and form clouds. All right, precipitation. So we know it falls from the sky. Air temperature determines which form. There are 4 types: rain, sleet, snow, and hail. We're going to look at each one of those. So go ahead and write what's underlined. So you've got rain, sleet's little pellets. You've got snow, which is going to be crystallized water. And then you have hail, which is big chunks of ice. Well, how does rain form? Well, if the temperature from the ground level up to the clouds stays above freezing, this will condense and actually form rain. So it's got to be above freezing, uniform temperature from ground level up to the actual clouds. Go ahead and write this. Well, how does snow form? Well, when the clouds are in an area of the atmosphere that it's actually below freezing, as the crystals form, as the water droplets freeze and form crystals, they'll fall. And as they fall, the temperature has to stay freezing all the way down. So the temperature from cloud to ground level has to be below freezing the entire way. It has to be even for it to stay crystals. All right, sleet. We get a lot of that here in Texas. Well, what forms this? Well, what can happen is you will have, say, rain or snow that will fall. It will actually go through a warming area to where it'll melt into rain droplets, and then it will drop through a fairly deep area of below freezing air, and it will freeze into little pellets, and that's what forms sleet. So again, it can fall as liquid or even snow, and it'll melt, and then it goes through a fairly deep area of cold air below freezing, and it actually can freeze into pellets before it reaches the ground. How does hail form? Well, here in Texas, during the spring, we get these really big storms. We get a lot of updrafts. We get a lot of low pressure systems where the air flows up, and that's what forms the big clouds. Well, what happens is there'll be an area of cold air that's below freezing. And what happens is these little pellets of ice bounce around in the cloud because they're not able to drop because air is still going up. it will actually bounce them around, and the little droplets that freeze will collect into big chunks of ice, and they become heavy enough to overcome the updraft, and they will actually fall to the ground as hail. So again, hail forms when these ice droplets and sleet actually collect together, bounce around in the clouds, so they get bigger and bigger and bigger and bigger, and then they get heavy enough to fall. So we'll go ahead and write what's underlined. All right, and freezing rain. Okay, we get a lot of this in Texas too. As the rain falls, say a cold front has just come through, and we know cold air sinks. So there's just a thin layer of cold below freezing air down near the surface. And what it does is it makes the cars and metal poles and different things like that actually freeze. And when the water hits the car or hits the mailbox or hits some type of metal sign, it'll freeze to the sign because it's below freezing. Well, it didn't turn into sleet because the area of cold air wasn't thick enough for it to freeze into ice pellets before it hit the ground. But it's falling, water's falling on the cars and different metals, and the metals are actually below freezing, and it causes to freeze to these objects. All right, so what are fronts? Well, fronts are just a boundary between two air masses. It's going to be cold and warm. It may have different densities, moisture, or temperature. Go ahead and write it. All right, a cold front. Pretty easy here. That's just when air moves in from the poles. Cold air is going to sink as it moves through, and you can see what happens is it's going to push this warm air up. So a lot of the rain that we get here in Texas comes during, say, wintertime. These cold air masses come through and push up the warm, moist air that comes from the Gulf, and that's what's going to give us the rain. So you can see right here, it is a line with a triangle, and it's usually going to be blue, and the colder air behind it. Right, what's underlined. All right, warm front, just the opposite. We get warm air coming in from the tropics. Warm air rises, and as it comes through, if it's cold here, so like in the spring when it's a little cold here and we start getting these warm fronts coming through, these warm fronts will come through and force that warm, moist air up. So that's why springtime here in Texas, we usually get the big storms and the tornadoes, because that warm air, as it comes through, will actually be forced up over the cold air, and that's when it condenses and can form the big, giant clouds where tornadoes can form. And you can see that a warm front is half circles and it's red. Warm air behind it. All right? An occluded front is just where a cold front catches up to a warm front. Stationary is going to be where a warm front and cold front run into each other and they just both stop. All right, so the weather map here. So you can see right here again, you've got high pressure system, no rain around it. Got a low pressure system here. You've got rain all around it because the air is being pushed up and it's forming precipitation. All right, isobars, the little lines that you see that go around these. Well, this whole area, let's say this is 40 degrees. Well, it's 40 degrees all the way around this line. Or maybe the wind speed. Maybe this is 30-mile-an-hour winds all the way around. It's kind of like a topographic map. This whole thing will be the same number all the way around. Go ahead and write it. All right, so one of the things you can see here is that when the lines are closer together, that's when the wind speeds are going to be higher. So around this low pressure system, we have this occluded front here. We got a cold front and a warm front coming through. You can see this cold air is pushing up the warm, moist air here, and that's what's forming the rain. Well, there's going to be lots of wind in this area. This low pressure system, all of these lines, these isobars here, means it's a lot faster wind. Whereas the high pressure system here, you can see that they're spaced far apart. It's going to be sunny and not very windy in this area. And the National Weather Service, two ways that they collect data is they use weather balloons or airplanes and things that they try to get up into the upper atmosphere, and they also get data from weather stations that are here on the surface.